Students, now we are doing the last topic in the chapter. We are having oscillation, free oscillation, force oscillation and resonance. Here we have to study this, we are taking rigid supports. Between to this rigid support, we are just tying a thread, the string. The string we are having, so the energy will transfer in the string from one pendulum to the other pendulum. This is the rigid supports at both the ends, and we are having pendulum. Here we are taking the pendulum, which is basically solid metallic sphere. We can take, I can name this as A. Another pendulum, if I am going to take in this line, all the pendulums are connected to the strings. Taking a pendulum here, this is hollow. One more pendulum, the length of this is smaller than this. Another pendulum, I am taking one more hollow, which is having the same length of that of pendulum A. I will just hollow again, and one more we are taking just the length is bigger. We are having a pendulum which is solid pendulum. These three we are having, that is B and C and D are hollow bob. The length of the pendulums are different. Here the length is more. Length of A and C. Length of A and C are same, so that the frequency will be same. B is shorter length and D is longer length. This is a pendulum which is attached to the string, so that the energy will transfer between A, B, C and D. Means initially when we talk about pendulum A only, this B, C and D are absent. When we talk about pendulum A, and suppose we give a small, when we displace pendulum A, when B, C, D are not present, only A is there, and if we give a small displacement, it is going to perform linear simple harmonic motion. It performs its oscillation. What happens? That type of oscillation is called as a free vibration. So the pendulum A, when it is alone, it performs its free vibration. When it is displaced from its mean position, it starts oscillating on its own. So that type of vibration is called free vibration, or it is called as free oscillation. So it will vibrate on its own with its own natural frequency, and the frequency of A will be given by, frequency of A is N, which is 1 upon 2 pi under root of, it is G by L. Okay, so the frequency of A is N is 1 upon 2 pi of G by L, depends upon acceleration of gravity. Fine. So that type of oscillation is free oscillation. When a single pendulum is there, when we are displacing the pendulum, disturb it, and then it starts vibrating with its own natural, vibrates with its own natural frequency. So that is called as a free oscillation. We can change the frequency of A by applying forced vibration also. Okay, so how we can apply forced vibration? By applying forced vibration, that is external periodic force, we can change the frequency of A. Now here, more further, suppose we are taking 4 strings now, 4 pendulum attached to the same string. Length of pendulum A and length of pendulum C is same. Length are same, the frequency of A and C will be same. Shorter length, we are having the shorter length more frequency. This B ka short length रहेगा तो जल्दी जल्दी से oscillate. And D is having more length, so frequency will be less. A and C is having same frequency. We take 4 pendulums, tie to the strings. Initially all B, C and D are all at rest. So initially we talk about that B, C and D are all at rest. Let us oscillate pendulum A with some frequency. When it is displaced from its mean position, it will start oscillating. After some time we are going to see that pendulum B, C and D also start oscillating with some other frequency. So they are oscillating with some frequencies other than the natural frequency of A. So that type of oscillation is called as force oscillation. So force oscillation is occurring in B, C and D due to transfer of energy to the string from A की वजह से A it is transferred to B, C and D, and they will start oscillating on its own with oscillating with the force oscillation, due to force vibration. So they are this type of oscillation where they are having other frequency other than the frequency of A is called as force oscillation. So they are oscillating. But what can you observe? You can observe that the frequency of C and the frequency of A, frequency जो है, it is same. A and C is same. Why it is same? Because the length is same. Because frequency depends upon length and axis. They are constant. If they are A and C का length is same, so they will oscillate with the C will oscillate with the same frequency with that of A, and it is going to attain a maximum amplitude of that of A. That is called as a resonance. When it is going to attain a maximum amplitude of same as that of A, because energy is completely transferred to C also. Maximum amount of energy is going to transfer to pendulum C. What about pendulum B? Pendulum B will be having more amplitude because length is less, but frequency will be different. D will have less amplitude. Okay, so they are having different amplitude and different energies because energy is not energy in B and D transferred is different. But C is having same frequency of that of A. So you can note down this. Frequencies are different. C is having same frequencies of A, and B and D are having different frequencies. And amplitudes are also less, because why B and D are having different amplitudes? Still the length is less, but why B and D are having different amplitude? Because energy transferred to C is maximum. Energy is proportional to amplitude square. So if energy transferred is in B and D is minimum, so amplitude is minimum, but to C energy transferred is more because of the same natural frequency due to the length L, so amplitude of C will be more. Moreover, we should know the graph which is given to you. We are having force frequency and we are having amplitude square. So when we take this event more time, when we repeat this, we can get the graph something like this. The graph indicates that at some particular frequency, for pendulum which is oscillating due to other pendulum, that is due to force vibration provided by A. This C is example, the C pendulum is oscillating with some frequency, but when it is going to attain this frequency, so initially suppose example is C, it is having different frequencies here due to force frequency, the amplitude is less initially, and when after some time you will see the amplitude of C is same as amplitude of A. The peak occurs when the force frequency that is applied to C due to A matches with natural frequency of A. So this peak is going to occur, for example, for C, when force oscillation is given due to A, it starts oscillating with some particular frequency, and this peak is going to occur when the force frequency matches with the frequency of A at this point, this particular point where F equal to Fr, force frequency for C given by A is equal to the natural frequency of A, F equal to Fr. This particular peak is called as, so you can see the C, for example, when it is having different frequency and at particular peak, that is when amplitude becomes same as that of A, so the frequency becomes equal. So this is called, at this peak, it is called as resonant frequency. So it is called as resonant frequency, and the phenomenon is called as resonance because the frequency of the force frequency and the frequency given by pendulum A A and C, they are same. So phenomenon is called as.